function. So the first thing we need to know well is what the parent rational function looks like. And so it is going to be these two curves in the first and third quadrant here. The domain of this graph is going to be negative infinity to 0 and 0 to infinity. That does not include 0, right? So it's defined everywhere except for 0. So you also may see that written sometimes as x. Sometimes you'll see it like written like this, x such that x does not equal 0. If we're in interval notation, then you'll see it written like I have it here. So you can plug any number into this except for 0. If we think about y, if you plug in 0, you're getting 1 over 0. That's a 0 in the denominator. We cannot divide by a number. Have I told you guys this? One of my high school teachers used to say, because it's easy to get mixed up, like, can you divide by 0? Does it need to be on top or the bottom? She used to put this on the board, and she'd say, 0 over a number is okay. A number over 0, no way. So you can't have that 0 on the bottom there. But if it's on top, 0 divided by anything is just a number. So can't have that 0 in the denominator for this. It's going to have a vertical asymptote at x equals 0, which is your x-axis. No. Have I got that back? I've got that backwards. Ooh, I need to fix that. Ooh. Hold on. I don't know if I can fix it. Not right now while I have this open. So we need to fix this. I'm going to mark it out. X equals 0. Which axis is that? That should be our y-axis. So if you have written that down, please fix that. Because the x-axis is certainly not vertical, right? And then the horizontal asymptote is the x-axis. I used this last year. Why did I not? It might have been, I probably did the same thing last year, and I didn't fix it because I can't go back to the original and fix it while you guys are in there, and then I never went back and fixed it permanently. So I need to make sure I do that. Write myself a note. Fix 2.2. Okay, so I want you guys to go to the next slide here, and if you were just looking on the screen, I need you to now make sure you're in here. I don't want you to see that. I want you to see the students so that you guys can't see what everybody's answering so far. So you're going to choose one of these four. Which one is 1 over x plus 2? All right, so it looks like there might be a couple of you that are still not in because that should be 18 right there. So go ahead and log into that Desmos classroom thing. We're not missing much. Do students.desmos.com. And I believe you should be able to get back into this to look at it after we get finished with it. So while this, I was trying to figure out how I could print this on paper so you'd have both, but I couldn't do it without it printing like 19 pages of stuff. So and I didn't want to screenshot everything. That would take forever too. But you should be able to get back and look at it. So let's see here. Okay. Most of you chose. Let's see. Oh, I meant to do this. Let's do this. I love Desmond's classroom. It's so cool. I'm changing your name right now. So up in the corner somewhere on yours, it should now have your name. These are names of famous mathematicians. So now I might call on you. I might say Erica Comancho. You got it wrong, but nobody knows who Erica Comancho is except for you, unless you announce to the class who you are. So I can pick on you without really being so embarrassing here. Even though some of these, the downside of this is some of these names I do not know how to pronounce at all. So you know. Anybody want to give that one a try? What do you think that is? No. Go. It's NGO with the over the. It's certainly not an English name. Moon is kind of a cool name. I'm trying to look for one I recognize, but they did not turn anybody into one that I really recognize. Usually there's a Euclid or a Descartes or something like that, but these are all ones I'm not so familiar with. You might need to give it a quick Google to see who you are. So, those of you who chose this one here are correct. Let me go back to the page so that we can see them more closely. So, this x plus 2, there aren't parentheses there, but it's like it has parentheses around that denominator. So that is going to, since it's in the parentheses, it moves it left or right. It goes the opposite direction, so you should be choosing the one that's moved to the left too, which would be this one here. Yours might be in a different place because they're randomized, I think. All right, questions? All right, try that next one. And if you want to go ahead and do an example 3 too, you may. Is it showing you guys these, like, can you see what people have answered on yours? Okay, good. I didn't. Sometimes it's set so it'll do that. I don't like to do that, though, because then you just pick the one most people are picking, whether you really believe it or not. Alright. Looks like most everybody's done with example 2, so let's look at it. Most everybody picked y equals 7. That is correct. Okay. So y equals 7 is, first of all, a horizontal line always has the equation of y equals. So you may want to add that to your notes there. If you have y, look up here something, right? If you have y equals some number, that is a horizontal line. And if you have x equals some number, that is a vertical line. It is backwards from the axes. The reason it's that way is, like, let's say I have y equals 7. If I plot a bunch of points where the y is 7, like 2, 7, and 0, 7, and negative 5, 7. If I plot those points, two, 7 is here, 0, 7 is here, negative 5, 7 is here. So all those points are going to be on that horizontal line because they all have that same y coordinate, all the y coordinate of 7. So the x equals, those would be vertical lines. So they would not be the correct answer. Here, this 7 right here moves this up 7. It's going to go to the right 3. So whenever we have our graph go up 7 to the right 3, I really don't want you opening another tab for Desmos, but I want you to see it now that we're talking about it. So if I go, see if I put that, oh wait, it was a -3, wasn't it? If I put that -3, it takes this red graph, it moves it to the right 3, and then +7 moves it up 7. Let me zoom out here a little bit. So if I put x equals 3 here, you can see that's the vertical asymptote that's moved over. Y equals 7, that's the horizontal asymptote. So whenever you move it up or down, that's going to affect your horizontal asymptote. When you move the graph left or right, that affects your vertical asymptote. You do need to be able to answer these types of questions without going to Desmos. I'm just going here to give you an idea of what this looks like. But we do need to be able to answer them without going to Desmos because there will be a calculator inactive, Desmos inactive section of the test. Whenever we get to it, eventually we're a long ways from that. Okay, questions? All right, let's see what we've got for example 3. All right, most students had chosen, let me go here, snapshots. Oh, wait. No, that's not. Well, I guess I'll just go student version. So this graph right here should go to the right 3 and down 1. So you'll go right 3, down 1, which is counting by 2s here. So right 3, down 1, that's not this one. Right 3, down 1, right here. That is the correct graph. A lot of times when I'm doing this, I think about moving that, origin point. So your original graph would look like this. I think about taking that origin point, it's got to go to the right 3 and down 1, which would mean it would be right here. So you'd have that shape this, which is what you're going to get right here for this one. Alright, so this will take us into our marble sliding portion. So these are kind of cool. I put some of these extra slides in here, but I did not make up all of this stuff. Desmos had already made it. Let me get rid of that writing there. Alright, so this one is just a practice one. If you click launch, it's already set up to work. You're trying to launch the little marbles so that they hit all of the stars. Okay? So, that is the idea. So, if I look at this one right here, if I click launch right now, I get most of the stars except for this one. So what I need to do is I want to change one number in the row below to fix the marble slide so that it'll hit all of those stars. So play with yours for a second, see if you can get it to work where it will hit all of the stars. And I'm going to go to the summary. Whenever you get it to work, it'll put a check mark over here. Alright, so it looks like most everybody has got this to work. Let's check out Moon's here. Moon changed his or hers to a minus 1.5. I think it was a plus 1 and changed it to minus 1.5, and that worked. Let's see. Erica here, though, just changed it to a minus 1. It still worked. Right, so with these, it's got a little bit of play there, but you probably had to change it to like something around negative 1 there. Okay, and that, of course, moved it to the right. Okay, questions on that one? All right, 7. So the purple graph here that is dotted, this shows the original graph that we have for our function. The red graph shows f of x equals negative 1 over x. So one thing I want to point out here, it does not matter if you put the negative in the top or the bottom or out front. Because of the symmetry of this graph, they will all look the same. That's because of the symmetry of the graph, right? If we put the negative in the bottom, it's reflecting over the y-axis. If we put the negative in the top or out front, it's reflecting over the y-axis, but it looks the same for this graph. So reflections, generally, we just put the negative out front for these. So try this one here. You want to try to fix this so that whenever you launch those purple balls, that they hit the stars there, but right now, nothing, so you guys have to fix it. Okay, so whenever I look, most of you look like you've got it to work. There's a few of you that don't have a line, so I don't know, Ames, right here, right here. For this one, that one doesn't have a line because of the number right here, but if you put a number right there, then what we can do for this one is, let's see, this is closer. If you'll put the negative out front instead of in that bottom, I think that it'll flip it this way, which will work even better. There. So like this person has the negative in the top and put a 12, which stretched it out, which works. Let's see. This person just put the negative out front. I think this is how it was to begin with. So that is the most simple way that you can do it. Let's see what Chow has here. So this person put the negative and then also change this to 2.8. Does it work? And it does get all of those there. See, Erica's has disappeared altogether. Let me go over here to Moon's. So Moon here, if you don't have it, this will work. The negative 4 over x minus 1 minus 2. Questions? All right. Okay, here's a new type of graph here. If we look at 1 over x squared instead of 1 over x, what can you tell me about the sign of x squared? If I plug in a positive number, what can you tell me about the sign of x squared? If I plug in a 2 or a 7 or a 28, is that x squared going to be positive or negative? It's going to be positive, right? What about if I plug in a negative? A negative 3, a negative 7, a negative 25. Still positive, right? So what this is going to do to the graph is it's going to make, instead of having the first and the third quadrant here, like the original blue graph, it is going to give us all positive. So it's first and second quadrant, everything's positive. And it is a little bit steeper here than what we have for the others. So another thing that we can do, this is just to show you something that you can do. You can also on Desmos restrict your domain. So if you put in these squiggly brackets something like x is less than 5, like originally, let me take this away. Originally this graph would have looked like this right here. But if I add those squiggly brackets as x is less than 5, then it cuts that graph off at 5. I'm going to put an x equals 5 there line just so you can see it. Let's make that dotted in blue. So it cuts that graph off right there, throws away everything here that's above 5, just uses that below. So if you're looking at like number 11, you can see right here, whenever I launch right now, all of the balls just fall straight down into the pits here. We want them to go over here. So try changing that one so we can get it to work. Okay, so I can see several of these. Like this person changed that 9 to an 11, which was plenty enough for the balls just to fall here. This one right here, they changed it to 20. It goes out a little bit further. You could get rid of the condition altogether, and that would work fine too. So you can change your domain. All right, vertical expansions and compressions. I just want us to play with this a little bit. So I'm actually going to add I'm messing this up bad. C of x equals 1 over x, just to have something to compare it to. If I have a small number here, like 0.6, you can see that it makes this graph steeper, stretching it out vertically. If I put a bigger number, like 5, or 4.8 here, you can see that it's compressing it. It's stretching it here. These are a little bit hard to think of. Gosh, that's hard to think of. Because as you stretch it, it's going to kind of take the curve out of that. So this is an expansion. Here, when we put that bigger number there, it's a compression whenever you put that number that's smaller. There. What happens if I go down into the negatives with that? It flips it, right? It flips it across there. So if you go down into negatives, that's because the negative is a reflect. It reflects. It also has either shrink or shrink there. All right, try this one right here. All right, most people chose the 20 over x. I also have some people that chose 1 over 20x. So if we put 20 in the top, that is going to be a vertical expansion. So it's stretching it out this way. If we put 20 in the bottom, what is that going to be? It's going to be horizontal. And a big number compresses, right? So it's going to be a compression. They're going to look, well, no, they'll be backwards from each other. Vertical stretch and horizontal compression. Rationals are hard to think about what they look like. Really hard to think about what they look like, in my opinion. So one thing you can do if you're having a little trouble, because it looked like those of us that did not think it was 20 over x, chose 1 over 20x, which is good because this plus 20 here would move up, right? And you guys recognize that was not correct. And this one, of course, is the original. So one thing you can do is you can pick a number to plug in. Like here, 4 or 5 would be good numbers to plug in because we get whole numbers. So if I do 20 divided by 4, I get 5. You can see I've got the point 4, 5 is right there on the graph. If I plug in 5, I get 4. 5, 4 is right there on this graph. So that lets you know for sure that this is the best graph. If you plugged in 4 here, you get 1 over 20 times 4 is a 1/80th, so it would be not correct. Okay, questions? All right, so for this one, you want it right now. It gets that first one, doesn't get the others. Try to fix it so that will work. So I can see lots of people who looks like it would work. This person, Richard, chose to change that top number to 15, and that worked out nicely. Let's see if Lynn did the same. This person chose 16, but it still worked, right? Because those stars have a pretty good area there. This person right here chose 20, which put the stars right on the line almost, but it still hits all of them, so that works out well. Basically, you needed to make that number larger there. Okay. All right, so this next one, it gives you this equation, y equals 1 over x minus 2 plus 3, and then x is less than 5. And it asks you to tell what would happen if you change the 5 to a 10. I'm seeing lots of explanations here. It'll extend the domain limit. The domain would go out to 10 and stop. It would end on 10. The graph wouldn't stop at 5. It would go on to 10 and stop. And this person, the one part goes longer or something, I guess, maybe. I don't know. I'm a little dumb. But you're right. Whoever this Erica is, you are correct. You are not a little dumb. All right. And then you can test it here on the next one. You can see if we change that 5 to a 10, it just does extend that graph out a little bit longer. There. All right. Try this next one. This equation, I don't know why the box did something weird there, but it should be in a box. You've got, that should be a y equals 1 over x minus 3 plus 4, and then x is less than 8. What's going to happen if we change the 4 to a 1 in the graph? So tell me what would happen there. All right, let's see what we've got here for these. Okay, let's look at the first two right here. It will go down 3 versus the graph would only go up 1 instead of 4. They are the same thing, right? Because this person, Richard, is talking about the graph as it is moving down 3 units because instead of taking the original going up 1, you're taking the original going up 4, you're only going up 1. So you would take this graph and it would move down 3. Several of you said something about 3. Others of you compared the 1 and 4, right? But it should move it up or down because this number's out here on the end of the graph, right? So I did see a left somewhere, but I think somebody changed that there. So it's going to move this down 3 units, or we could say that it goes up 1 instead of up 4. This person said the graph wouldn't have a center point at 4, 4. It would have a center point at 4, 1. So that's another good way to explain what's happening there. Okay, questions? All right. All right. So all these next ones are challenges, and this is what you're going to work on for the rest of class. So we're going to kind of do this first one together. So it gives you nothing, right? I do want to point out that you are supposed to try to complete this with only rational equations. Okay? So some of these, it would be really easy just to put a line in. So you could just put like a straight line and it would work. But I do not want you to do that. Right? I want only rational equations because we're trying to work on rational equations. So we're going to do this first one together. So if I start with just 1 over x, that gives me this graph right here. So as I look at it, I'm thinking it's not going to work like it is. What do you guys think I should do to it? It looks like it probably needs to go up some, right? So if I put like a +5, that looks pretty good. But if I launch it, I'm still missing this right here. So try 5.5. Let's see if this will work. That'll get it right there. Or another thing I could have done, if I change that 1 to maybe like a 3, it's going to make that graph, it's going to change how steep the curve is because it's a vertical stretch there, and I think that would probably also get it. So there could be several different ways that you get the stars to go away for those problems. So you have got lots of challenges that you're going to look at. So like for example here, it would be probably easier on this one to do this with maybe something linear here, because it's going to be kind of difficult to get this here. So remember, you can do something like this, put a negative in front. Hang on, that's not really good. Don't put that negative in front. You can maybe move this one up 4 and then to the right 2. That's not there, but it's getting closer to where it might. If I launch this right now, it gets that bottom one. So it's getting closer, right? So you can move this around different ways. You could go back 1 over x. I could probably do something like this, move it up 2 and to the left 1. No, that's not left. Left 1. And then I could stop my domain. X is less than 4. Probably not 4, probably 3. And then, it's not working. But I could maybe do another. You can add more than 1. So if I move this one, and put a negative here, move it up 2, we do? That'll work. There's an easier way to do that, but I did get them all doing that. So you can add more than one rational function, but do only rational functions here. Okay, does everybody get the idea? Some of these are really hard to do. I have actually not sat down and tried to do every single one of them, but some of them are really hard to do. So what we will do for this one, the first one does not count as an extra credit point because I just showed you how to do that one together. I don't think any of you copied me on that second one quickly enough to get that just straight for me. So the first one does not count as extra credit, but all of the others that you have here for the rest of the slides can be a point apiece added to your test grade that we just took. Okay, they must include only rational functions. Okay, only rational functions, and so if you use a line or a quadratic or something like that, you don't get credit for it. It's got to be only rational functions. And you don't have to do them all. So let's say that you can't figure out number 7. That's fine. You get a point apiece for the ones that you do complete. Okay? Any questions? The very last one is going to ask you to create your own, where you put your stars wherever you want.